We're looking at the sky from here in North Georgia. This is Friday, September 11th, around 9 p.m., facing south, where we see a sky filled with stars. Now, the stars form patterns on the sky that are leading us to areas called constellations. Constellations are specific areas of the sky that have defined borders, kind of like states on a map. Anywhere you point on a map of the United States, you point within the borders of a state. And anywhere we point on the sky, you point within the borders of a constellation. These are the borders of some of the constellations that are up now. It's bright patterns of stars in each area that act as the landmarks so that we can find a constellation. The first constellations that we'll look for in the sky form a bright pattern of 3 stars high above, and they're called the summer triangle together. So there's 3 stars that form this pattern. We have Vega, Altair, and Deneb, and they're very bright, but each one is actually in its own constellation. So we're going to start with Vega. Vega is in the constellation Lyra, the harp. We look for Lyra by looking for a faint diamond shape just off of Vega. I'll put up an outline so we can see that a little bit better. And this represents a harp. In Greek and Roman mythology, it was supposed to be a harp played by Orpheus, the first harp. Now the star Altair is in the constellation Aquila, the eagle. So we look for Aquila by looking for sort of a double triangle shape that runs through Altair. That's sort of the wings of the eagle. In Greek and Roman mythology, this was an eagle that sometimes brought lightning bolts to Zeus. And finally, we have Deneb, which is in Cygnus, the swan. We look for the swan by looking for a cross shape of stars. Deneb is sort of at the top of the cross. It's sometimes called the Northern Cross. It's also the body and wings of the swan, Cygnus. Again, from Greek and Roman mythology, a lot of our constellations come from those cultures, but there are different people around the world. In different cultures, they had their own constellations. And so for people in the Shoshone Native American tribe in Wyoming, these same stars represented a grizzly bear. The grizzly bear was said to be climbing a tall mountain, and ice and snow were sticking to his fur, and the ice crystals started to trail away across the sky. And that formed what we know of as the Milky Way. It's the hazy path. It's running right through Cygnus the swan. I'll brighten it so we can see it better. The Milky Way is actually our own galaxy. So our galaxy is a spiral galaxy. It has a flat disk, flat like a pancake, made of clouds of gas and dust and stars. We're inside of it, so when we see it in the sky here, what we're seeing is a side view, an edge view of that pancake of clouds of gas and stars stretching across the sky. We're going to look for an interesting object in Cygnus. In our view here, it's kind of on the left side of that cross constellation. Now, this object is called the Veil Nebula. Nebula is just a word that means cloud. So this is a faint cloud of gas in space. It's actually very large on the sky. It's about 6 times wider than the full moon. We'll bring it up so we can see it in the sky. That faint circular shape there. And the Veil Nebula is a supernova remnant, so it's leftover gas from a supernova. We're going to take a closer look at it by zooming in on it. This is kind of like looking at it through a telescope. Now, typically you wouldn't see this object with the naked eye. It's very, very faint in the sky. You can see parts of it, bright parts of it, with a telescope. But we're going to zoom in on it and see sort of the whole thing, kind of like we're looking at it through a telescope. We have telescopes here at UNG. We actually are about to wrap up construction on our brand new facility with new telescopes. It's out at our observatory site. It's called the North Georgia Astronomical Observatory. However, they may not open to the public until next year. For updates, you can check out their Facebook page. But nonetheless, we're going to zoom in on the Veil Nebula here in the planetarium. So here we see the whole Veil Nebula much more clearly, a little closer up. And we're going to take a look at how it would have formed by seeing an artist's depiction of a supernova. So here we have a massive star out in space, much heavier than the sun. It starts to run out of fuel to fuse at its core, and so the star is going to undergo a massive burst of light and energy, and then the outer layers of the star are that expanding shell of gas. They've been thrown off quickly and violently, like the outside of the star is exploding away. And that's what we see here left over, that remnant of the Veil Nebula. So the Veil Nebula is 2,400 light years away. So that means the light we see from this object took 2,400 years to travel to us through space. We can also look at that expanding shell of gas, wind the clock backwards, and see when the supernova would have been seen from Earth. And it would have been seen around 10,000 to 20,000 years ago. So a star that exploded long ago. Let's take a look at a photo of the right side of the nebula to show us an even closer view of some of that gas there. So what we see in this picture is basically an area called the Witches Broom. It's gas from a supernova that's slamming in to interstellar gas, the gas that's just hanging out between stars, and it's heating up, it's glowing, and that's what we see as this Witches Broom here, sort of a glowing filament of gas. There's also a little inset there that was taken by the Hubble Space Telescope with even more detail. Another supernova remnant recently made the news, and that's because the remains of its dead stellar core, the source of its supernova, was recently identified. The supernova is much further away than the Veil. It's outside of our galaxy, 168,000 light years away. It's in a small satellite galaxy of ours. It's called the Large Magellanic Cloud, and you can only see that galaxy from the southern hemisphere. The supernova in it is also very young. The Veil Nebula we see here was from a supernova that would have been 10 to 20,000 years ago as seen on Earth. But this one was seen on Earth only 33 years ago. It's called Supernova 1987A. Let's take a look at a photo of the supernova remnant. From the supernova 1987A. What we see here is data combined from different telescopes. There's different colors of light here. The blue light is the highest energy light that you see there. It's actually X-rays taken by the Chandra X-ray telescope. The green is visible light, like we'd see with our eyes, taken by the Hubble Space Telescope. And the red is very low energy radio waves, taken by the ALMA array of radio telescopes. Now, that blue and green is showing us where a shock wave from the supernova is expanding out. It's actually where it's passing through a ring of gas that was released from the star before it went supernova. That was slower moving gas, and the shock wave caught up to it and it heated it up to high temperatures that we're seeing there. The red, though, towards the middle is showing us some cooler gas and some gently warm dust. And so that blob of dust, there's sort of an inset there on the left that we can see more of the detail of the blob of dust that's near the center. And that picture is what ALMA released recently. Basically, it's showing more detail than we've ever caught of the center of this supernova. And we think hiding, obscured by the dust in that blob, is the dead core of the star. It seems to be a young neutron star. Basically, we measure the temperature of the dust, and it matches really well with what we expect a young neutron star to be able to heat that dust to. It's also a bit off-center, and that matches up really well with computer simulations of this blast that show it's not perfectly symmetrical. There would have been a kick to the core, shooting it sort of to the side, and we see it in the location we'd expect it to be. And so this young neutron star is buried in there, and we've identified traces of it, and it makes it the youngest neutron star that we've ever detected at only 33 years old. We'll zoom away from the Veil Nebula and look for some more constellations.